Welcome back to another episode of BigQuery Spotlight. Today we're talking about BigQuery data governance so that everyone in your organization can easily find and leverage the data they need to make effective decisions while minimizing overall risk and ensuring regulatory compliance. Let's jump in. The term data governance is thrown around quite a bit, but what does it actually mean? Data governance is everything you do to ensure your data is secure, private, accurate, available, and usable inside of BigQuery. For us, governance starts during data onboarding. Let's say your team has received a new request. Someone from your e-commerce department wants to add transactions data into a new BigQuery table. The first step in ensuring governance is understanding the data. For example, figuring out where the data is coming from and what information it contains. In this case, the transactions will be extracted from a database, and you already know the schema. So let's start by creating a new blank BigQuery table. Next, you'll need to make sure that sensitive data is protected. To do so, you'll want to categorize the information in your new table. For example, marking specific columns as having personally identifiable information. You might remember that tables can have labels. While labels are a great way to easily categorize BigQuery objects, they are a bit limited and can't be used for specific columns. Lucky for us, BigQuery has deep integrations with Data Catalog, Google Cloud's data discovery and metadata management service. Data Catalog automatically tracks technical metadata for BigQuery assets. So we can already find our new BigQuery table and see things like column names, descriptions, and when it was created. But the really cool part is that you can create schematized tags that act as annotations to capture metadata. We've already created a tag template that tracks data governance information. So now let's fill it in and attach the tag to the email column. Great, now we're tracking that this entity contains customer email addresses. But you might also notice there's a comments column that stores free-form text customers have added to their order. There's a chance that some of these rows contain more sensitive information. This is where DLP comes in. DLP, or Cloud Data Loss Prevention, is Google Cloud service designed to help you discover and protect your most sensitive data. With DLP, you can create an inspection job that scans comments for email addresses. DLP can scan data that lives in Data Store, Google Cloud Storage, or BigQuery, and can send you an email with the scan results. Save the results back to a table inside of BigQuery, or even write the results directly into Data Catalog. Many BigQuery users choose to leverage an orchestration tool, like Cloud Composer, to build data onboarding pipelines. For example, you might load your transactions data in a lockdown staging project inside of BigQuery, and kick off a DLP scan when new comments are added. The results will be listed in the staging table's metadata inside of Data Catalog. If the scan shows that any sensitive information is included in a comment, then you can also kick off a de-identification workflow, where DLP replaces PII with something like an asterisk or a hash symbol. Then the new data is finally appended to the production BigQuery table. Now that you've de-identified and classified your data, you're ready to design access policies. To understand data access in BigQuery, you need to familiarize yourself with Identity Access Management, or IAM. If you haven't already watched our video on BigQuery IAM, I recommend pausing and taking a look. We've linked it in the comments below. Great, so on to data sharing. When it comes to granting access to BigQuery data, many administrators choose to grant Google groups representing your company's different departments access to specific datasets or projects. So policies are simple to manage. Say you have a project that stores your organization's e-commerce data. You might give the e-commerce team the BigQuery data viewer role in this project. Now, someone on the e-commerce team needs data from a different team, like the product development department. You may be inclined to just grant them access to that dataset. Instead, you could use an authorized view or an authorized UDF so that your e-commerce analyst can get limited access to product data while still keeping more manageable team-to-project permissions. So this all sounds great, but what about those PII columns that we flagged before in Data Catalog? You definitely don't want the e-com team to have access to those, unless they have special clearance from security. With BigQuery, you can control access to specific columns using policy tags from Data Catalog. Here we've created a taxonomy, which classifies the level of clearance needed to access different types of data. Anyone who needs access to our highly sensitive data should be added as a fine-grained reader to the high resource. So in our case, we'll just add the ecom PII clearance group. Next, we can apply these as policy tags to columns in our BigQuery table, marking the columns with PII as highly sensitive. And to take it one step further, maybe you don't want all e-commerce folks to get access to the transactions data. Instead, each analyst should only be able to view transactions for the product category they work on. You can control access to specific rows in BigQuery using a row-level access policy, like the one we're showing here. Between storing data in different containers and leveraging authorized views, UDFs, policy tags, and row-level access policies, you have a lot of options for sharing data in a secure manner. Check out the documentation below for some more guidance on pros and cons and general best practices for policy access. Okay, so we've onboarded our dataset and we've shared it. The last step we'll talk about is ongoing monitoring, including ensuring that data is accurate. This is where data quality comes in. There are lots of different tools that allow you to declare quality validation tests by writing custom assertions using SQL. For example, you may want to check and make sure that you don't have any duplicate entries in your table. We've actually created an open source framework for data quality validation that's included in the comments below. And keep an eye out for Dataform, our tool for developing SQL pipelines, which will be open to new customers soon. Just like we mentioned before, you can use an orchestration tool like Cloud Composer to programmatically run these tests and alert you if something seems wrong. You can also use the Data Catalog API to make sure that quality metadata is added to tags and is easily discoverable. Aside from monitoring quality, you might also want to monitor who's accessing the data and how they're using it. Well, you're in luck. In a few weeks, we're diving into monitoring your BigQuery deployment, so be sure to tune in. And remember, stay curious.